Hello, this chapter, chapter 5 of the Managerial Econ class covers investment decisions and how to determine if an investment is in a project is profitable. So you may, hopefully you remember back from Finance 302 or from your undergrad finance classes where you calculated the net present value. I'm just going to go over that real quickly here. You're going to be covering that in the finance class. So I'm just covering it because it's mentioned in this textbook in chapter 5, but you're going to be covering it in detail when you're in the finance class. So let's just go through these two simple examples here. All right, so first of all, let me go back up to the top. So remember that investment decisions are a trade-off between current sacrifice and future gains. And when we do discounting to figure out if the future gains are going to be greater than the current value. One of the main formulas that we use in discounting is to calculate the net present value. So we're calculating the net present value of these future cash flows of our project. And so we just bring the value of these cash flows back to the present value at the rate that we're having to pay our investors. In other words, we have bondholders, we have stockholders, we're having to pay them a rate of return. And so if the net present value is 0, that would mean that we would be breaking even. If the net present value is positive, it means that we should accept the project because it means that we've added value to the firm. We're paying our investors this project is making money. In other words, we're paying our investors the rate of return and we're adding value to the firm. So if you have, if you can accept all of the projects that you're analyzing, you would accept all of them that have a positive net present value. If you can only, if it's mutually exclusive or you can only accept one, then you would accept the one with highest net present value. Okay, so let's take a look at the net present value formula. So if you remember back, the present value formula, forget about the N right now, the present value formula is simply the future value divided by 1 plus the interest rate or the discount rate to the nth power, N meaning the number of years. So if it's the net present value, I should actually have a summation sign here. It's the sum of all of these future values of these cash flows divided by 1 plus the interest rate to the nth power. Okay, so the future I is the rate and N is the number of periods. So let's take a look at this example. This is in section 5.1 of the textbook. This is a project. Let's say that a company is buying a fax machine or something. The machine is costing them $100 and they're going to be able to earn $60. It's going to generate $60 in cash flows each year for 2 years. So they're out $100. So that initial cash flow is negative 100. In the first year, they're going to get $60 in cash flow. In the second year, they're going to get $60 in cash flow. The cost of capital for them is 14%. That's what they're having to pay their investors. All right. So what we're doing here then, the net present value is the negative $100 plus the present value of $60 going back 1 year. So that's 60 divided by 1.14, 1 plus the rate of return, plus the present value going back 2 years. In year 2, they got a cash flow of $60. You divide that by 1.14 squared. So when you sum all this up, negative 100 plus the answer to this cash flow, net present value of this cash flow plus present value of this cash flow, you end up with negative $1.20. So they're losing money. You would not accept that project. All right, so this next example is for project 2. So here they have a the initial cash flow cost is negative $100, and this project is going to earn them $115 the first year, and then it's over. So we're just going to take negative 100 plus $115 divided by 1.14. And we sum this up and we get 88 cents. So this is a positive NPV project. So you would accept this project. What this means is saying that this project added 88 cents to the value of the firm, even after paying 14% to our investors. So since it's positive, you would accept it. Okay, so I just wanted to, run down this, run this by you real quickly, just so you could become familiar with this, but you're going to be looking at this in much more detail in the finance class. Okay, now they also talk about break-even analysis in this chapter. So a shortcut and more of an economic slant to this, to try to find out if a project is profitable or not, is using break-even analysis versus net present value. So let's take a look at break-even analysis. So if you can sell more than the break-even quantity, it's profitable. So here's the formula for the break-even quantity. Q equals F divided by P minus MC. Okay, what does all this mean? Okay, this means the quantity, your break-even quantity is going to equal your fixed cost divided by the price minus the marginal costs. Now, remember, or you'll learn in this chapter, that marginal costs and variable costs are the same thing. They're interchangeable. So this is the break-even formula. Your break-even quantity, or how much you should sell to break even, is going to equal your fixed costs divided by the price minus the marginal cost. All right. Okay, so then in so look at page 54, that's where they talk about this formula. Now, in section 5.5, they talk about what if a company has to make a decision if they're not profitable, when should they shut down? So in other words, at what price should they actually cease operations? We just looked at the break-even price, but what if they're, when should they shut down? When it's called a shutdown decision. Okay, so this deals with the avoidable costs. So note that the break-even price, this should say is here. Okay, note that the break-even price is the average avoidable cost per unit. Okay, so what is avoidable cost per unit? It depends. Okay, so in the short run, the avoidable costs are only the variable costs. So in the short run, meaning a year or less, you have that plant, you've got this plant and equipment, you can't, you cannot shut a whole plant down in the short run. So in the short run, the only thing that you have control over are the variable costs. So those are your only avoidable costs. So the only avoidable costs in the short run are the variable cost. In the long run, though, the avoidable costs include both the variable costs and the fixed costs. And that's because you can't alter these fixed costs in the short run. But in the long run, you could close down a store, you could close down a plant. So an easy way to think of your fixed cost is to think of it as a one-year renewable lease. You're stuck leasing a store or leasing property for a year. And so that's a fixed cost that is only avoidable in the long run. So if you shut down, you're going to lose revenue, but you're going to save these avoidable costs. So you should shut down if revenue is less than your avoidable costs, or if the price is less than the average avoidable cost. So you can look at, make sure you look at page 56 for a more detailed explanation of this, but this is the main point. Now let's look at this example. This is a shutdown decision. So a lot of times, okay, here's your break. Remember this break-even formula up here. A lot of times what economists look at when they're thinking about, when they're trying to make a shutdown decision, is instead of looking at the quantity, they're asking, well, what price should I have? In other words, how low can the price go before I have to shut down? So let's look at this example in terms of prices. Okay, so in this example, the fixed costs are $100 per year. The marginal cost or the variable costs are $5. And the quantity is 100 units. So the question is, how low can the price go before it's profitable to shut down? Well, the answer depends on if you're talking about in the short run or in the long run. Okay, so let's back up. So remember, in the short run, the only avoidable costs are the variable costs. So the answer in the short run is easy. In the short run, only the marginal costs are avoidable. So you would shut down if the price goes to $5. You see here. So if your price goes to $5, you're just, that's your shutdown decision because you can avoid those variable costs. But what about in the long run? How low can the price go in the long run before you should shut down? Well, then you have to include the fixed costs. So we're going to put everything in this formula. And so this is Q equals 100. The fixed costs were $100 divided by, we're solving for price, minus your marginal cost or your variable cost, the $5. So this is going to tell us, now that we've included the fixed costs, this will tell us at what price it would be profitable to shut down in the long run. So here's you just solve for P here. So I'm just multiplying 100 times P and 100 times 5. So we've got 100P minus 500 equals 100. And then add 500 to each side. So I end up with 100P equals 600. P equals 600 divided by 100. P equals $6. Therefore, in the long run, you would shut down if the price goes to $6. Okay, so again, this is a pretty short chapter. Just take a look at this. After you look at the synopsis, you may want to reread these notes and then read the chapter. Now, the next chapter is on elasticity, and that is a little more detailed chapter. So when you have a chance, take a look at chapter 6. And then once you've seen the chapter 4, 5, and 6 synopses, then you'll be able to do the homework set. Okay, goodbye until next time.